So in the last class, we ended by introducing Bayes' theorem, and we did an example with Bayes' theorem. And hopefully that example kind of showed you that sometimes things are not as obvious as they seem. Sometimes we need to do a little bit of statistical analysis in order to get, sensible results. And what we're going to do now is, before we start into a new topic, I did want to talk a little bit about how Bayes' theorem can be approached from a more practical way. Because I know we know how to solve it, we know how to solve this equation, we know how to plug in values, but I think it would be very helpful if we understand what these values actually mean from a practical way. So what I would like to do now is to reorder this equation. Just move some terms around. It's still the same equation. It's not changing anything. I'm just gonna express it or write it in a slightly different way so that we can explain what each of these terms means. Okay? So let's see. We have the probability of event A, the conditional probability of event B given A, the probability of event B, and we can see that all this is equal to the conditional probability of A given B. Okay, so why do I reorder it this way? Because I want you to understand what Bayesian statistics, right, tells us. I mentioned in the last class that Bayesian statistics essentially consists of updating your probability, updating your probability with new evidence. So how does that work in this equation? Well, if we look at A and B as events that occur, right? So things that happen, two different things that happen that, as you can see, they're not really independent of each other. They affect each other. And if A is really our target event, so A is that event that we're trying to quantify, then the probability of A is essentially going to be our initial probability, or as you may know, we call it the prior probability. In other words, the probability of A, the prior probability, is what we know initially about this event that we're trying to study. So for any event that we're trying to study, our initial knowledge is what we call the probability of A, at least from a mathematical point of view. But then the new evidence, right, comes in the form of the probability of B. So if we look at this, which we're going to call new evidence, the question is, well, what does this really mean? Well, you can see that we have a conditional probability. In other words, the probability of B given that A happened. But then we also have the general probability of B occurring, over the entire sample space. So what this new evidence is essentially doing is it's giving us, right, the support that this new event or this other event B will give towards A. When we do more examples throughout the rest of the semester, I think this will start to become a little bit easier to identify. In the previous example we did, we kind of had to give you the specific events so that you can plug those in. But the idea is this new evidence is telling me, how does B really affect A? And you can see it in terms of, well, what's the probability that B would actually occur? What's the probability that B would actually occur given that A has already occurred? So we're looking at two different things. We're looking at the probability of B occurring, one over the entire sample space, one only over the overlap or over the event, right, that A has already occurred. And when we combine these two things, our prior probability and our new evidence, then we have an updated probability or posterior probability. Now this is important because what happens is our posterior probability then becomes our new or next starting point, right? We have an initial value, an initial set. We update it with new evidence, so now this will be our next starting point. And then we can update this posterior probability with another new set of evidence. So just like the example of the rocket entering the atmosphere, as new evidence occurred and new evidence was evident, well, that sounds like a little bit repetitive, but as new evidence was visualized, right? In other words, as the trajectory was being delineated, then we could use that new evidence to then get a posterior probability. But then that would become our next starting point. And then the newest evidence will give us another posterior probability, and that becomes our starting point. So it's almost like an iterative process where we start with an initial value, we update it with evidence to get a new value, and now this becomes my initial value. Update that with the newest evidence, get a new one, and so on and so forth until you end up being able to solve whatever it is you're trying to obtain. So I just wanted to get that idea of how Bayes' theorem can be approached a little bit more practically. You'll notice that whenever we go back to Bayes' theorem in the class, I'm not going to be saying, the conditional probability of A given B. Instead, I'm going to be explaining or giving you examples in terms of initial knowledge or prior probability, new evidence, and then posterior probability. And you should be able to take those terms and identify them with their mathematical counterparts so that you can end up solving your problems. So that covers it for our general introduction into Bayes' theorem.